In this video I'm going to work out just an individual integral here. The integral of 1 over the square root of x plus 1 plus the square root of x dx. Now, later on, after we do some algebra manipulation here, this is basically just going to be a u-substitution. But the trick on this one is recognizing those algebra steps that you need to take before you start integrating. Now, if you remember when you were working with limits a lot, and you had this, square root plus square root in the bottom and or in the numerator, we did a lot of multiplying by the conjugate to get rid of that. Okay, so that's the trick that we're going to start on this one. We're going to algebraically multiply by the conjugate so that we can clean up that denominator right there. So I'm going to have 1 over the square root of the x plus 1 plus square root of x. Alright, now the conjugate, if you remember, is just that bottom with the opposite sign. So I'm going to be multiplying by the square root of x plus 1 minus the square root of x, and then I've got to also do that on the top so that I am multiplying by a form of 1. Okay, now doing that, we're going to have, let's just go ahead and keep going sideways here. Alright, on top, 1 times that numerator is just going to leave that numerator as the square root of x plus 1 minus the square root of x. Now, the point of multiplying by that conjugate is because this is the factored form of the difference of two squares. So we can real quickly multiply that out by squaring the first term, which will give me an x plus 1. Putting that minus in there, squaring the second one, which is just going to give me an x. Alright, now that real nicely allows me to cross out the x's, and I just have a denominator of 1. So I have simplified this original integral down to the integral of the square root of x plus 1 minus the square root of x dx. Okay, now at this point we probably need to look at this as a whole right there. That set of parentheses around there is going to make it a little bit nicer there. If I take this now and break this into two separate integrals, I'm going to have the integral of the square root of x plus 1 dx minus the integral of the square root of x dx. Alright, this one over here is going to need a u-substitution. This one over here I'm going to be able to integrate straight. Alright, now I am going to go ahead and take this up to the 1/2. Alright, so let's do that. Let's come down here and do that. So we'll have the integral of an x plus 1 raised to the 1/2 dx minus the integral of an x to the 1/2 dx. Alright, I think people are going to be able to see that a little bit better. Okay, now on this side I am going to need a u-substitution right here. So I'm going to let my u be the inside part, which is the x plus 1. I'm going to take the derivative of both sides, so du is equal to derivative of x there is just going to be a 1 dx. Okay, so then let's go sideways one more time. So then this will be the integral of a u raised to the 1/2, substituting dx for what that equals. That's going to be a du minus, I'm going to go ahead and leave this as an integral and in terms of x so that we can integrate in both steps at the same time. Alright, integrating here, we're going to add 1 there, so we'll have a u raised to the 3/2 and the reciprocal in front, so 2/3 minus this one will be in terms of x. Again though, adding 1 will be an x to the 3/2 and multiplying by that reciprocal in front. Now I can add the plus c. Alright, now I need to replace u with what originally I said it was going to be. So we'll have a 2/3. Right here we'll have an x plus 1 raised to the 3/2 minus the rest of this will remain the same. 2/3 x to the 3/2 plus c. Technically at that point you are done. However, if you want it in the same form, since that original equation had radicals in it, you could turn this back into radical form. So a 2/3 square root of x plus 1 to the 3rd power minus the 2/3 square root of x to the 3rd plus c. Technically both of those answers would be correct. It's just if you want it in the same form as the problem that you originally started with, you would want to do that. So pretty much a straightforward integral problem. little u-substitution there. All right, the main thing is realizing how to get started, that you need some algebra manipulation to that original equation first before you start. Multiplying by a conjugate there is really, really common when you've got a sum or a difference of radicals inside your problem. Definitely thanks for watching. If the videos are helping, don't forget to subscribe to the channel and also share with your friends. Thanks.